A ball is attached to a string is made to rotate with constant speed along a horizontal circle. The string is attached to the ceiling and makes an angle of theta degree with the vertical. The tension in the string is T. What is correct about the horizontal component and vertical component of the net force on the ball? The question is not asking us to calculate force, but the question is asking us to calculate the resultant force. The first thing that we have to do is to draw the free body diagram. To be able to do that correctly, we have to identify the force or forces acting on the ball. In this case, the question mentioned that the ball is attached to a string, and we have to recall that the tension is always pointed away from the object. So therefore, tension will be along the string, but pointed away from the object. Any object that has mass will have weight. That is a force, and it is always pointed towards the center of the earth. In this case, it will be pointing downward. These are the only two forces that is acting on the ball. Now, because the ball is moving in a circular motion, we clearly know that the ball is accelerating towards the center. And we also know from Newton's second law that if the acceleration is towards the center, that means that the resultant force also must be in the same direction. What we have to recall here is that resultant force is not a force. That means resultant force is a vector combination of force or forces. Means that there must be an actual force pointing in the direction of the resultant force. The weight is 90 degrees to the acceleration. Any force that is 90 degrees to the acceleration does not contribute to the acceleration. That means in this case we can ignore the weight for now, because the weight is not contributing to the acceleration at all. So now our only choice is the tension, and we know that tension is not along the x-axis or y-axis. That means that we have to resolve the tension. When we resolve the tension, we have one component of tension pointing this way, and we have another component of tension pointing this way. The horizontal component of the tension will be T sine theta, and the vertical component will be T cosine theta. Now we have a force, an actual force, that is pointing in the direction of the resultant force. And this is the force that is contributing to our horizontal net force, our resultant force there. So that means for the horizontal, we have T sine theta. So this will be our answer for horizontal. Now, if we look into the vertical component, the ball is not moving up and down. That means the object, the ball, is in equilibrium. It's not accelerating in the vertical. Therefore, there is no resultant force in the vertical. So in the vertical, our resultant force has to be 0. So the correct answer will be D.